So today is lesson 5. Now, just in reference, starting the recording, so just talk about the videos for just a second. A few people said that the videos were not in the playlist, which was kind of weird because when I went and looked at the playlist, they were there. I think YouTube had some issues with the playlist. If ever you can't find a lesson video, all you have to do is just go to YouTube and just search my name and the course code, and it'll come up. So there's actually a few ways. If for some reason the video you're looking for is not in the playlist, there's a couple ways you can find a recording. So the first one is just search Rich Freeman and search our course code. And it should come up, although you're going to get, you can then filter, if you want to filter for this year, it'll come up. That's odd. I'm not exactly sure. Maybe YouTube isn't aware it's 2021 now. The other thing you can do is just go to the channel. So just go right to the root of the channel, and it does show you the videos in chronological order. So you can always find them if for some reason you're having trouble finding a lesson video through the playlist. Search either my name in the course code or just search my name, go to the root of the channel, and then you can find them through here. No, we don't need to submit Lab 2. I removed Lab 2. So you only have assignment 1 to do. Justin, you asked about, what you're asking about is two-factor authentication. What I'm going to suggest, if we look at the syllabus, at our plan for the course, the last 2 weeks are our tutorials, where in groups, you guys get to choose a topic, do some research, and help teach the rest of the class. So Justin, what I would recommend you do is make a note of that. If two-factor authentication, that's something that interests you. After reading week, we'll brainstorm topics we want, and we can add that to the list. And you can request to be involved in that. So rather than me teaching you, you might have the ability for you with some classmates to learn how that works and then share that with the rest of the class. Is that okay? Does that work? Okay, so file that one away. So what you're talking about is two-factor authentication, and we'll have the ability to look at that in one of our last couple lessons. So what we want to do today is we want to talk about NoSQL databases. We're going to set up MongoDB. We're going to introduce models into our application we've been building. We have controllers and views that already come with our Express Generator site we built last week, but the models aren't included in it. You don't need the models for your assignment, but we are going to need the models for our in-class application and for your second assignment in the course. So we're going to use models, and we're going to use Mongoose. Mongoose is kind of like the Node equivalent of the entity framework. So in .NET, we used entity framework as the library so that our ASP.NET files could talk to our SQL Server database. In our PHP class, we use the PDO library as the bridge, the interface between our PHP code and our MySQL database. When we're working in the mean stack world, we're going to use Mongoose as that kind of bridge, that interface between the models in our web application and our MongoDB on the back end. Mongoose isn't the only library available, but it's kind of the standard one. It's the most popular data access library for getting Node and MongoDB to talk to each other. So we will do that as well. And then you just have your assignment 1 to work on, which is due next week. Last week in class, we looked at deploying our applications to Heroku. I've also put up, I should have put this up in last week's class, there is a quick tutorial here, so if you need a reference on how to deploy your site. You actually can deploy node sites to Azure as well, although probably not many of us have Azure credits left. I've put up a couple of links here. If you're interested and you want to see how you would deploy Node to Azure, maybe you have your own Azure account, you're using it for other stuff. So there's a couple of links here, a couple other walkthroughs for that. And using Heroku, it's here. All right, so let's dive into, we want to dive into Nosql and MongoDB today. So we're going to kind of look at it at a high level, and then we want to set it up, install it, and get configured and start using it within the app, the Node Express app that we started creating last week. Has anybody ever worked with a NoSQL database before of any kind, whether it's MongoDB or something else? Okay, there's a no. Anybody else? No. Nope. Okay, that's fine. That's my expectation. We're going to take NoSQL right from the very beginning. Okay. All right, so here's my follow-up question, and I suspect I know the answer, but do you know anything at all about NoSQL? What is a NoSQL database? Do you know anything about it already? Even if you haven't really worked with it. Okay, so Maggie, that's one of the key characteristics. There's no strict schema. And yes, Justin, you're right. We don't actually use SQL commands. Barak, absolutely. So it's non-tabular. So our relational database tables, right? Every table, visually, it looks like a grid of columns and individual rows. And NoSQL databases, they don't have that structure. Okay, so what I'm going to do, I'm going to actually pause my recording. We're going to look at two quick videos, like they're each maybe 2 or 3 minutes long. So the first video, what I want you to do, and I'll pause my recording as I show it, I want you to note, you guys have already listed some of them in the chat. So what differences are described between a relational database and a NoSQL database? So we'll do that. We'll look at that one first and talk about that in general. And then our second video is a promotional video direct from MongoDB that looks at MongoDB specifically. So it's going to touch on many of the points about NoSQL databases in general, but it's also going to highlight some of the specific benefits of using MongoDB specifically. So I'll just pause my recording. Videos are short. So our first one is our question, what differences do you note between relational and NoSQL databases? So based on that little video, is there anything else we could add? Yep. Okay, that's a good point, Maggie. So the links are right here, Hung. They're in this item. So under the intro to NoSQL and MongoDB, the 2 videos are here and the spreadsheet link is here. No problem. It would not be unlike me to forget. So anything else we can say? Yeah, right? We can add capacity whenever needed. Nick, I'm actually going to break those out into two. It's kind of 2 elements. So it is fast on cloud servers. And if we think to what we know about Agile development, right, Barak, that's the key one. So fits Agile development as allows for flexibility, right? So in an agile approach, rather than defining in great detail everything before we build our application, in an agile approach, we build and revise as we go. So in this case, NoSQL is a good choice because it allows us to evolve and modify the database as we're building an application. Whereas that's really a challenge with the relational database. With a relational database, we're much better to design and build it ahead of time. And it's much more challenging to restructure the schema once our application is under development. So NoSQL works really well with that kind of iterative agile approach. All right. So those videos are here. I think they're fairly good introduction. I've got a few slides of my own, so I'm going to go through about talking specifically with Mongo, how we set it up, and then how it's going to work in terms of our Node and Express application. And the slides are right here for you to reference, getting started with MongoDB and Mongoose. I think I'll actually bump these out so that they're bigger. Yes, you can use, there are other document databases. So there may be, traditionally we do use SQL Server NIC with ASP.NET, that's kind of the standard, but you may have an application where it makes sense to use a NoSQL database, and you can. There are a number of other popular NoSQL products. I'm not sure if Microsoft, I imagine they must have their own, but we should actually look that up. Google has one. So when I teach Android to the computer programming students, we use Google's Firebase, Firestore cloud database. There's SQLite, there's CouchDB. There are a number of other NoSQL products. Right, that's what it is. Thank you, Justin. Thanks for looking that up. I knew there was one. I have heard of it. Azure Cosmos Db is Microsoft's proprietary, globally distributed multi-model database service for managing data at planet scale, launched in 2017. So generally classified. So I have heard of Cosmos, thanks, but I have never worked with it. So I don't have any experience with it. So that would probably be a good choice if you wanted a NoSQL database on the back of an ASP.NET application. So really, it evolved around scaling, and Barak mentioned that we've got this, tabular structure and relational database. So if you think about it, we build a relational database, then what happens when we need to add a new field or some of the data rules change, right? Our customer has an input form and suddenly they say, I need more information from the customer. Or we're getting in data that looks like this, but now we're getting another source of data and it looks totally different. So our structure, our schema has to change. So I think Ginal mentioned the idea of NoSQL does, instead of storing records, which is relational database terminology, NoSQL stores what it calls documents. And typically those are in key value pairs. So generally, because there's no schema, the idea is these documents are designed to be scalable and really fast. Because the database doesn't have to parse through the structure, it can read the documents much faster than a relational database can read records in a tabular structure. We can even have documents that have different formats, and that format might evolve over time. So for example, today we have a document that has 3 pieces of information. We want to add a new field to our application. We can now just start saving a 4th piece of information in each document. We don't have to change anything in the database. the way we would with a relational database. We can also nest documents inside of other documents, which eliminates things like foreign keys and joins, and we'll look at an example in a minute. So it suits cloud well because cloud services are designed to scale automatically. The more usage we have, the more servers are rolled out, the higher our cost. So what does a document look like? So here's a sample of a MongoDB document. So in this class, I'm going to try to get away from using the terminology, the relational database term, a record, and we're going to talk about documents. And instead of records being stored in tables, in the NoSQL world, we have documents stored in collections. And different documents in the same collection can actually have different schemas. And I know this kind of makes your brain hurt when you're first looking at this, because everything we know about databases is tables have structure and all the data in a table is supposed to fit that same structure. But the reality is that isn't always true in the world of our applications. And I can actually give you a real world example of this. So one of the research projects I'm involved with, we have a number of students building a web application, and we're actually using Node, Express, and Mongo for this. And in this application, we are collecting data from a whole number of different IoT devices. So there are HEPA fans and filters, there's pressure sensors, there's a temperature sensor. So each one of these types of devices sends different data into the database. For the HEPA filters, we want to know how fast the fan is spinning and how much power it's consuming. For the temperature sensor, it's sending us temperature information. The airflow sensors are sending us an air pressure reading in cubic feet per minute. By using MongoDB, we can actually store all of the data in a single collection, even though the structure for each type of device is different. We don't need to create 3 separate tables. So here you can see MongoDB will automatically give an identifier. Now they're called identifiers. They don't really use the idea of primary keys, but it will automatically create a key called _ID, and it will automatically give a unique ID value to every document. And then this is basically just a JSON object, as Janelle mentioned earlier. So you can see how one document can contain different subdocuments. So here, address, rather than being a single value, it's its own subdocument with street, zip code, building, and coordinate values. And this is where you can see how a whole document in NoSQL can actually store different kinds of information, right? In a relational database, so this is something like a restaurant and a inspection date. In a relational database, these would be in 2 separate tables. We'd have a restaurants table, we'd have an inspections table, and every inspection would have a restaurant ID foreign key, as Maggie mentioned earlier. In NoSQL, we can actually store the whole thing together. We can store a restaurant document, and inside it, we can include the grades from different days. So this makes it faster to query this information because we don't have to do a join and search in different parts of the database for different pieces of information. We can store them all together in one single JSON document. So how does it work then if we don't have foreign keys like relational databases and we don't use joins? How do we determine these relationships? Like, when do we nest data inside? When do we nest documents inside of another one? Let's have a look at a few of the rules. I shouldn't say rules because it's more guidance. There actually aren't really hard and fast rules about relating data in MongoDB. So this article was originally written in 2014. It was updated last year. So rules of thumb for our MongoDB. So here's one. So what we have to look at, I won't go through all of this. So a one to few relationship. So in this case, for example, we've got one person has multiple addresses, but because addresses is probably not going to be unlimited, theoretically it could be, but realistically for most people it won't. In this case, we typically will use a nested array. So we'll have a person object with information about the person, and then we might have addresses. So for example, if this was, a site like database like Blackboard, within your student record, we might have your overall grades. Yeah, you'll get lots of grades here, but you're not going to get millions of them. Maybe a few dozen grades. So it would be possible to nest your grades directly inside of your student record, for example. So this is the most common case. It's like a one-to-many, but the many side isn't going to be that big. We can just nest them. If we have a true one-to-many, like let's say customers and orders, then we would create two separate documents. So here they've got, for example, product and parts. So they would create those as separate documents and link them together. So that's kind of like a foreign key idea. And then they have, we don't even worry about one to squillions, but this is more like the foreign key idea. So where the many side could be really, really large, in the one document, we include the object ID of the related document, kind of like a parent-child. So that's more similar to a relational database join. So there's no hard and fast rule. When we encounter a relationship in NoSQL, we have to ask ourselves, how big is the many side? Is it a few, or is the many side likely to have an unlimited amount of data? If the many side won't be that big, then we can just nest the many documents inside of the parent document. Otherwise, we'll want to break them into two separate collections and relate them based on the object ID. So MongoDB has actually been around since 2007. It's a pretty mature product. The name is kind of funny. Here's where the name comes from. The idea was it was supposed to support humongous volumes of data. So they took the word Mongo out of the word humongous, and that's where the name was born. All the data in MongoDB is stored in a form of JSON, which is called Bison, which is binary JSON. So our JSON objects like this are converted into ones and zeros because that's the fastest way to store data and read data. So it's super fast. It also works really well when we're working with Node and Express because everything in Node and Express is already JavaScript. So we don't have to serialize or convert from a database format into JavaScript. Our database format is JavaScript already. It's supported by a lot of cloud hosts, as we saw in the videos. It automatically takes care of unique IDs for all of our documents. We don't have to do anything. And as Justin mentioned earlier and Maggie mentioned, we're not using SQL queries. So MongoDB has like a simple query language that's much like using Entity Framework. So it has a find method. So if we wanted to find everything in the posts collection, our command would be something like db.post.find. And if we wanted to pass in a where clause, we just pass it in as a JSON object, where the title is equal to Mongo. So we don't need full SQL syntax, much like when we were working with Entity Framework in .NET. So MongoDB is free to use. We can run it locally, which I used to do in this class, but MongoDB now has a cloud service called Atlas, and they give us half a gig of database space for free. We can create one database. So we're going to do that. I'm going to go through the process. We're going to create a database, and you can use that same database both for our in-class application as well as for your assignment 2, which you'll need in the later part of the course. You can't create, but they only give you one free database. So that's why we're going to use it for both our in-class lessons as well as your assignment. So you can run it locally for our in-class app, but obviously that doesn't work for your assignment if your database runs locally. So I'm just going to go through the setup and then we'll do it together. So we'll go to mongodb.com, we'll create a free database, which they call a cluster. So we'll create a cluster. We will walk through this whole process together. It's going to give you a quick overview. So it's got different pricing. So if you want multi-cloud, multi-region, it's 13 cents an hour. We're just going to pick a free shared cluster. And it'll ask us to pick a server. So they use actually both Azure and AWS. So we'll just pick one of their free tiers and we'll make sure it says sandbox. That'll mean there's no charges. And we'll go ahead and create the cluster. So that's going to build a database server. Then we're going to have to create a user account, a username and password that we can add to our node code to connect to the database. So kind of like when we created a database in Azure, similar sort of process here in MongoDB. We create the server, create the database, and create our own username and password. We'll then connect to the cluster, and we can do that through, they have a free tool, kind of like a MySQL Workbench or a Management Studio, a free downloadable tool called Compass that lets us connect to our cloud database and then manipulate the data, read it, manipulate it. So we'll install that as well. And then simple commands I've documented here. So to do an insert would be something as simple as this. db.collectionname.insert, and then we just pass in a JSON object. And you notice from these two examples, we can pass in different schemas. In the first insert, we have a name and a type. In the second one, we have name, a type, and we also have an on sale property. But it's schemaless, so MongoDB doesn't care. And we can use find, update. And after we do that, so we'll set MongoDB up, and then we want to start getting our node application to talk to it. So we're going to use Mongoose. Again, this is our data access library. We'll have to install Mongoose via npm. And Mongoose is an object document mapper. So it's a way of letting our node application interface and connect to our MongoDB database. So our code will look something like this. We'll install Mongoose and require it. We call mongoose.connect and we pass in our database connection string. And then we can interact with our models. So we're going to build a game model. We're going to build a models folder and a game model. We'll require Mongoose, and we're going to create a new schema. So pretty similar to creating a model in ASP.NET, really, except we have to do it manually. We'll define it in JSON format. So we will have a schema, but the schema lives in our models instead. It doesn't live in the database. And then we'll use our model to do some CRUD. So for today, we want to be able to add and hopefully read a list of games from the database. And then we can work on editing and deleting next week. So we're going to create an add form and a games model to work with our games controller. So this is where we're going today. I'm going to recommend that you download the local MongoDB Compass tool. I will put the link in the chat, but you can also find it on Blackboard. Justin, I believe you emailed me about this. I did respond to you. So the issue is the folders. So you may have installed MongoDB Compass already. So Compass is free. So this is the tool that allows you to connect to your database from your local machine. You can also use the cloud interface, but I would recommend you download and install. So you can get the link on Blackboard, MongoDB Compass, or you can grab it from the chat. It's free. So Justin, please make sure that your package.json is in the root of your application. It should be in the same folder as your app.js. When I looked previously, it wasn't. Okay, maybe you can re-upload your repository to GitHub and send me the link again, please. And when you run the application, make sure you're running it from the folder where app.js and package.json are in, not from the folder above. That may help. Okay, it is, so go ahead and download and install Compass. We are about due for a quick break. So let's take a pause here. We'll come back at 1 o'clock and we will get our MongoDB set up. So then we'll do that first. Okay, we will be back at 1 o'clock. Justin, feel free to send me the repository link again once it's updated. Thanks.